Great to see you here again. In this new video I will talk about variance, standard deviation and the coefficient of variation. Variance, standard deviation and the coefficient of variation are parameters that will help us to describe how the data are spread around the central value or the average or the mean. Now, before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, you will be informed about it. By the way, my name is Luc de Koster, founder of the Koster Academy. So let's start with this new video. First of all, we already were looking at the different measures, and we looked at the measures of central tendency, mainly the mean, median and the mode. We were looking at measures of variation, which include the range and the interquartile range. And now we're going to look at the variance and the standard deviation. And we will also combine mean and the standard deviation together when we will be looking at the coefficient of variation. The other elements like the empirical rule and the standardized sample data will be considered in the next videos. Variance of a population or a sample, what we see is in fact that we are going to look at the average of the squared distances of the data values relative to the average, to the mean value. And it's basically the square, the average square distance, which is a parameter which will indicate us what's the average, what's the distance, the square distance relative to the central value. Why are we squaring the values? Well, the fact is, if we would have xi minus the average, we would have on the left hand side a negative value, on the right hand side a positive value, and when we look at these parameters, it would finally bring us a value, the two sides would compensate each other. Now we want to know the total quadratic distance from a point, from the different points to the average. We calculate the average, and when we have a population, we indicate the variance as sigma square, and we divide the total of the square distances by the number n, which is the size of the population, it's capital N. Now we can do the same thing when we look at the data values, when we have a sample. Here we do it a little bit different. We also write the variance as s to the square, and we calculate the square distance, the total square distance from the different data points to the average of the sample, and we divide by n minus 1, which has to do with the degrees of freedom, because we have the average and basically we only have n minus 1 degrees of freedom in this case. Now, when we are looking at this, we have the similar values, similar definitions, but we see that when we look at a population of value n and a sample of the same value n, that basically the sample variance will be larger than the population variance. Based on this, we have a squared value, so we have, for example, the millimeters to the square, and we cannot really compare that with the real data we have. We define the standard deviation, and the standard deviation is the positive square root of the variance. And when we have the population standard deviation, we have the variance to the square, sigma to the square, and we take the positive square root of this variance. The same thing we do for the sample standard deviation, and here we have in fact the same thing. We take the sample variance, or s to the square, and we take the positive square root of this element. So basically we have now what we call the standard deviation, either from the population or from a sample. And it's a very important parameter, because this parameter shows the average distance from the data points to the average. And that's what we're going to use to define, for example, the normal distribution, which is a specific, very interesting distribution we can use, which is based on two parameters, the average and the standard deviation. Also define what we call the coefficient of variation. And the coefficient of variation, also given by CV is the ratio of the standard deviation to the mean expressed as a percentage. The CV is used to measure the relative variation in the data. So basically we have here a relative variation, and it makes it possible to compare different distributions with each other. When we look at the population coefficient of variation, so the CV index population, we have the standard deviation divided by the average, sigma divided by mu, multiplied with 100%, it's expressed as a percentage, and we also have the sample coefficient of variation, which is basically the same. CV of the sample is equal to the sample standard deviation divided by the sample average x bar multiplied with 100%. And now we have in fact identified a lot of very interesting parameters. We know how to define the average or the mean. We know what's the median and the mode of the distribution, but also we found parameters for variability, for variation, like in this case the standard deviation and the variance. That was it for this video. In the next videos we're going to apply these new defined terms and parameters, and we're going to continue that in the next videos. We're going to define the normal distribution and so on, and we will look at some applications, practical applications of this. Now, that's all I wanted to teach you in this video, but before finishing, do not forget to click the subscribe button, click the bell button, and every time there is a new video, you will be informed about it. Thank you very much, and bye-bye.